So to start coding, as usual, we start the code with keyword module followed by the module name, the same as the Verilog file name, and then followed by bracket and semicolon. Inside the bracket, we can straight away declare input and output. So we have three input in our case, in our formula, X, Y, and Z, and then one data output of F, and the regular input, which is the clock, has to be there also, and the input to the entire RTL system, the start trigger and the stop output, and then end module. It's a good practice to put the input output port vertically so that we can give command to them individually. So since we are using 6.8 fixed point format for all data input and output, the total bit used is 24 bit, so we declare as 23 to 0. Even at this point, we can already save the Verilog file. Click the floppy disk icon, then select the file, right click, select compile, and then compile selected if we only want to compile the selected file. So you see the error here in the message area. So the reason is obvious in this case because module name cannot be started with number. So we have to give something not number to start with. Let's say M, stand for metric, and this name, this file name .v must also be changed to the same name. So we need to remove this one. Remove but don't delete. Then in the folder, we need to rename the file with the same name also. And the original offending file will have to be closed also. Then we add the new file with new name. Double click on it, so we get this one. Now we can compile it. So now it is successful. For this first step, coding of this RTL system, we will start at the very first step, coding the multiplexer part with the control signal, and then we will check whether or not the value at the input of the multiplexer will appear at the output of the two multiplexer. To do that, we will code it first and then we will continue straight away with the test bench to test this first part. This first part is actually the first points or the first junctions that the data flow in. And to test that, we need to also code in our control unit the first state where the start signal is 1. Okay, since these two multiplexers are just multiplexer 2 to 1, we can code them using conditional operator. We will call this wire as multiplicand and the other wire going to the multiplier, this one, as multiplier. So considering that, we code the two multiplexer using an assignment to the two wires from two conditional operators like this. The selector is first or second selector line or control line. Then what is this value? This value is actually the pre-calculated value of square root of pi. So in your assignment, please pre-calculate any constants or any operation on constant. Do not make any code or circuit to calculate that. Pre-calculate the whole operation on the constant. So how do we get this value? Let me write down the calculation. You can find this in the PowerPoint slide. So this is the calculation. We pre-calculate the value of square root of pi in decimal first, and then multiply it with 2 to the power of 8, which is 256, and then you have to multiply again with 2 to the power of negative 8 so that the value is the same. Why do we do this? Because our notation is 16.8 fixed point notation. Then if the fraction part is equal to or more than 0.5, we round up. Then we convert only the integer part to binary and put it in the one of the entry in the multiplexer. This one to this one. You should realize that we can also write this as this means the same constant in Verilog. The next is we have to declare a few variable. We have to declare multiplicand and multiplier over here, and the number of bit has to match the number of bits in X, Y, and Z, because these are the values that goes in multiplicand and multiplier. And first or second is actually the selector 2 to 1 multiplexer, meaning it has only one bit. And it is a register because it has to come from control unit, and this is a wire because this has to be assigned in data unit. Then next is, since we are using this signal, first or second, we need to give it a valid value. This has to be done in control unit. So this is the code. When start is 1, meaning when the process is being triggered, we give to the signal a 0 value so that we can do the multiplication between X and Y first. And then when start is not 1, meaning it is 0, we give it a 1 so that we can do the multiplication between Z and square root of pi. And we also make some remark here about control unit being triggered by positive clock edge and data unit being triggered by negative clock edge. Why do we do this? Because we are assuming positive edge comes first, then followed by negative edge of clock. Control unit has to be triggered first so that it is ready to trigger the data unit, which is the one that is controlled by control unit. Having said this much so far, now it is time for us to compile this code. So it looks like it's successful. Next is to simulate this using a test bench.